In this video, we'll be covering the snap gauge. When we're done with this video, you'll be able to identify the pieces and parts of the snap gauge. You'll be able to use a parts master to set the zero of a snap gauge, and you'll be able to measure parts for tolerances using a snap gauge. In this demonstration, we're going to be covering the components of the snap gauge. This is our insulated handle. It isolates our body from the physical metal frame. Inside the insulated handle, we have our hex wrench, which we will be using later to make the adjustments on our snap gauge. This is our identification disc. This is our locking wheels. The locking wheels physically hold the column to the frame. This is our adjustment wheel. This is the wheel that we will be turning to increase and decrease the dimensions for the part. This is our guard. There are two guards here and here, and they prevent the gauge from making contact and knocking off calibration. This is our upper anvil and our lower anvil. This is the backstop. This is the part that your part is going to physically rest against when making our measurements for consistency. Looking at the dial, we have our bezel and we have our bezel clamps right here. So this right here, we can loosen the clamp, and it makes it to where we can adjust the calibration on our dial, and tightening this down makes it to where it will not rotate. So those are the components of the snap gauge. In this demonstration, we're going to take a look at the snap gauge master part. For this particular part, it is machined to 0.5000 inches. These parts should be protected against damage, always stored inside of their box, and only taken out when they are to be used for confirming or setting the zero of your snap gauge. In this demonstration, we're going to be using our parts master to zero our snap gauge. Taking the parts master out of the box, we're going to examine it for cleanliness and any damage. We're also going to confirm that it is the correct parts master for the snap gauge. This one is 0.5000. So we can confirm that this is the one that we want to set our snap gauge with. The next step that we're going to take is we are going to loosen these two components right here ever so slightly using our Allen wrench. So we'll put these in just like this, and we can rotate it so that they loosen up. We don't want to make these very loose, just ever so slightly loosened. We don't want this column flopping around because it will make it more difficult to zero the snap gauge. The next step, we're going to physically insert the parts master into the snap gauge and make our adjustments. So the parts master physically fits in between the lower and upper anvils, and we're going to center it on them, just like that. So with the parts master centered on the anvils, we will take our Allen or our hand and we will make adjustments to our adjustment screw. When we make our adjustments, we want to watch our dial rotate, and we're going to take that dial and that needle and we're going to have it rotate up to the zero mark. And what that's doing is, as we're rotating this, it's bringing the upper anvil in contact with the parts master and makes it so we can have an accurate reading. So you can actually see where the dial and the needle are moving. We're going to bring that right up to the 0, and we're going to stop. If it goes a little bit past, that's okay. We can actually use the bezel for our fine adjustments. So we're going to take our bezel and we're going to make our fine adjustments right there. With that being done, then we're going to lock back our lockouts. So these are going to be locked out, and then we can remove our parts master. Once we have tightened our locking wheels and removed our parts master, we want to reconfirm the 0, just to make sure that after we tighten everything down, nothing shifted. So taking our parts master back out of the box and placing it in the anvil, or in between the two anvils, we can physically examine our gauge. And we can see how our gauge is reading 0 on this one. So that confirms that our 0 on our snap gauge matches the parts master 0, and we can put our snap gauge into service. In this demonstration, we will be using the snap gauge that we have set to 0.500 that we set in the previous section. We will be measuring a series of parts for tolerance. The tolerance that we'll be looking for on these parts is no less than 0.500 and no greater than 0.501. Taking the first part in your hand, we're going to insert it into the snap gauge in between the upper and lower anvil. We should hear an audible click. With the part in the snap gauge, we're going to examine our dial and the needle on our dial and confirm that it falls within the tolerances of 0.500 to 0.501. This one reads right at 0.5008, so this part passes. Taking the next part, we're going to do the same thing. We're going to place it in between the upper and lower anvil. We should hear an audible click, and we can see that the gauge reads almost 0.503. So this part is too large and it fails. The last part, we insert, we hear the audible click, and we see that it actually falls short of the 0.500 because it reads on the negative side of the 0. So this one is too small and it also fails.